Hello student, how are you? Welcome my channel, The Learn Physics. In my previous video, I've already discussed the Newton's law of motion and different type of forces related to it. Now, today I will be discussing the impulse and derivation of work energy theorem and all types of numerical related to it. Now, let's start. We know, first of all, impulse. If force act on a body for time t, then product of force and time of action is known as impulse. If F force acting on a body for time t. So impulse I equal to, look at this, F into t. Okay? Now we know F equals to mass into acceleration into time. So this is the m into acceleration to change of velocity divided by time into time. So this is cancelled out. So look at this, impulse is equal to mv minus ma. Therefore impulse I equals to change of momentum. Okay? Now what is impulsive force? If a large force acts on a very short interval of time, then it is called impulsive force. The hitting of cricket ball with the help of bat, the hitting of nail with the help of hammer is the example of impulsive force. Now difference between impulsive force and impulse. Impulsive force is the cause of impulse and impulse is the effect of impulsive force. Impulsive force is a large force act for very short interval of time, but impulse is the product of force and time of action. The unit of impulsive force is the Newton, where unit of impulse is kg meter per second. The dimension of impulsive force is the dimension of force that is m t minus 2. Whereas dimension of impulse is dimension of momentum that is m t minus 1. Impulsive force produces large acceleration for a very short interval of time, but impulse produces change of velocity. Okay? Now we solve a problem relating to impulsive force and impulse. Look at this. Two bodies of identical mass are placed side by side. Now impulse I act on this body and a force F acting on it when they meet. Look at this. The velocity of this body in which impulse act is v equal to impulse by mass, and acceleration produced in this body a equal to force by mass. Okay? Now the displacement in this body, look at this, s equals to v into t, that is I by m into t. Okay? And here displacement produced s dash equals to half a t square, that is half f by m into t square. Okay? Now when they meet again, s equal to s dash. Now here I by m into t equal to half f by m into t square. Okay? So look at this. Here this cancel out. T 1 t cancel. So t equals to, look at this, 2I by m. So after that time t equal to 2I by m, they again meet. The derivation of work energy theorem from Newton's second law of motion. Now look at this. We know the force F equal to mass into acceleration. We also know the square of final velocity equal to square of initial velocity plus 2 into acceleration into displacement. Now from here v square minus u square equal to 2s. So So v square minus u square by 2s, this equal to a. If we put the value of acceleration this in this equation, we can get, look at this, we can get f equals to m into v square minus u square by 2s. Therefore, f into s is equal to half mv square minus half mu square. Okay? No problem? That is work done equal to change of kinetic energy. This expression is known as work energy theorem. Okay? Now look at this. If v equal to 0, that is final velocity 0. So this term becomes 0. So the stopping distance s becomes, look at this, half mu square by minus f. That is stopping distance equal to initial kinetic energy divided by resistive force. If the initial velocity of the body be double, then initial k becomes 4 times. So stopping distance becomes 4 times. Okay? When initial velocity becomes 3 times, the kinetic energy becomes 9 times. So stopping distance becomes 9 times. Look at this. A bullet is moving at a speed of 250 meter per second, penetrates the limb of a tree by 5 centimeter. We have to calculate the force exerted by the limb on the bullet. Okay? Now let's start. Now look at this. Here initial velocity is 250 meter per second. Final velocity v equal to 0 and s equals to 5 centimeter, that is 5 by 100 meter. Okay? Now we have to calculate the force acting on it. If we apply the formula work energy theorem, half Fs is equal to, look at this, half mv square minus half mu square. Look at this. Here f into 5 by 100 and this is the 0 minus half and mass of the bullet m is equal to 10 gram. Okay, so here look at this, half into 10 gram, so 10 by 1000 kg and u equal to 250 meter per second whole square. So look at this becomes f by 20 and this is the, look at this is the half into 10 to the power minus 2 into 62500. Okay? So look at this, F equal to, this is the 6250 Newton. Okay? Resistive force act on the bullet by the limb is 6250 Newton. Understood? Next. Look at this. A car moving at a speed of 40 km per hour is to be stopped by applying brake in next 4 meters. The mass of the car is 2000 kg. We have to calculate the resistive force. Now look at this, the data given here, u equal to, look at this, 40 km per hour, that is 40 into 5 by 18. This is the meter per second. Okay? Final velocity v equal to 0. Distance covered s equals to 4 meter. Now we have to calculate the resistive force F. From work energy theorem, Fs equals to half mv square minus half mu square. So look at this. Here minus F is equal to half mu square divided by, this is the s. Now look at this, this is the half, this is the 2000 and this is the, look at this is the 200, look at this is the 200 by 18. So this is the 200 by 18 square by, look at this, s is the 4. So look at this is the 250 and this is the 100 by 9. So this is the 10 to the power 4 by 81. Now this becomes 3.1 into 10 to the power 4 Newton. As force is negative, so it is the resistive force. So resistive force is 3.1 into 10 to the power 4 Newton. Understood? Look at this. The raindrops of radius 1 millimeter and mass 4 mg are falling at a speed of 30 meter per second on the head of a bird person. The raindrops covers distance equal to the radii before coming to rest. Now we have to calculate the force acting by each drop. Now look at this. Here distance S is, this is the S. Now this is the mass M. Now look at this. This is the initial velocity U. Okay. And finally come to rest. Rest means this is the V equal to 0. Okay. Now we have to calculate the force applied F. Okay. Here S equals to 10 to the power minus 3 meter. Okay. Mass M is equal to 4 milligram, that is 4 into 10 to the power minus 6 kg. U is equal to, look at this, 30 meter per second. V, look at this, V is equal to 0, and we have to calculate F. Now from work-energy theorem, half S equals to half mv square minus half mu square. Okay, no problem. Now look at this. So this is F is equal to, look at this, this is 0. So this is the minus half mu square divided by S. Now data given minus half m 4 into 10 to the power minus 6 u 30 square, and this is the S. This is the 10 to the power minus 3. Now look at this, from this data, this is the 2 and this is the 900 into 10 to the power minus 3. So this is the 1.8 Newton. Okay, and this is the negative side. So resistive force applied by the head is 1.8 Newton. So force acting by the raindrop is 1.8 Newton. Okay, understood? Many thanks for watching this video. I hope you will understand this video. If you are new, please subscribe my channel to get further new videos.